Hi all, my name is Gulshan Banu, working as an assistant professor, AI and DS department, SNS College of Engineering. Hope you're doing great. And in the continuation of the previous video, I'm here with the same topic, and I'm going to explain some of the other concepts that is related to this Lda, Pca and manifolds. Okay, in the previous class we see what is the limitations of logistic regression. We saw what is Lda and how the Lda is being plotted and how it is being dimensionally we have certain dimensional reduction process, and we saw what is Pca is all about, and we saw certain examples, simple examples that is related to it. The next concept that is related to this Lca Pda is the curse of dimensionality. So now what is this curse of dimensionality? The curse of dimensionality in deep learning is all about, it refers to the phenomenon where the performance of a model significantly degrades as the number of the features or dimensions in the data increases. It actually leads to challenges like data spatiality, difficulty in finding the different kinds of patterns, and also there is an increased computational cost, or making it harder, or it can't be able to understand or something like that. Okay, now there are certain key points that is related with this curse of dimensionality, that is nothing but the data sparsity. The next is the distance metrics between less meaningful data, and overfitting risk and computational complexity. Now why do we need this curse of dimensionality is what all about I told you. You have to reduce the number of dimensions in order to increase the performance of the data. So how do you calculate this curse of dimensionality is, you have a certain formula, that is volume of hyperspace divided by volume of bounding hypercubes, that is the different hyperspace that is being evolved plus the different cubes that is evolved with it. Okay, so we will be applying it with the different formulas that is associated with the hyperspace and hypercube, and through that we will be finding out the formula, and we use this just because to decrease rapidly with increasing the number of dimensions. So see, in this you have an image of a dog which is being plotted in each and every manner, but see, when it is scattered in each and every order, it is really very difficult for you, and it is an high dimensional space, and it is difficult for you to understand. But when it is bounded with different kinds of space and sphere or cube, it is easy for us to execute it. No, what is this curse of dimensionality is, it is the high dimensional data. If it is difficult, it's really difficult to handle. Difficultly, it increases the rapidly when the number of dimensions or need to transform the high dimensional data into low dimensional data, and there are different classifications that is being executed. As I've already told you, this is Pca, Lda and manifolds process. You have non-linear methods of this manifold learning also. See, now we have different manifolds process. So now there is a correlation between this manifolds process, Lda, Pca and the curse of dimensionality. Now what is this manifold learning? Okay, manifold learning in machine learning or deep learning is nothing but that helps to analyze and visualize the high dimensional data set by finding the low dimensional structures. Just finding out the low dimensional structures, you can use it. Okay, so it is a powerful technique for many of the complex data sets, and it is used in data analytic sciences to cluster the larger amount of data sets, etc. So this is how the data points in high dimensional space appears in low dimensional space. So this is how it has been converted. A manifold process, it has been stretched and it has been given in a easier manner for us to understand. This is certain examples of how those high dimensional data is converted into the dotted lines, and it is being converted to a flatter manner for us to understand in a single process. So now what is this manifolds or something like that? It is the metric learning, is a machine learning technique that can be used in deep learning to establish the similarity or dissimilarities between objects. It can be used to perform the task like clustering, information retrieval, and KNN classification. So what it actually aims is, it reduces the distance between similar objects, increase the distance between dissimilar objects, learn a perceptual or representational function that maps the objects into embedded systems. So these are certain process that is involved in the manifolds. So now, in machine learning, a distance matrix is learned over objects, which means that model can be trained to provide a number of any pairs of objects. This number of represents the degree of similarities between the different kinds of objects. So this is all about the process of Lda Pca or manifolds is all about. We saw what is curse of dimensionality, and we saw how manifolds learning is being processed, and the complete process of the machine learning, that is or deep learning process, that is evolved in this three process. I hope that you understood the topic in an efficient way. If you have any doubts or queries, you can directly reach me through the comment section that is being given. Thank you for being connected.